Hello everyone. Today we're gonna learn about depth first search algorithm. Besides breadth first search algorithm that we have learned in the previous tutorial, depth first search is another powerful graph algorithm. Before you continue, make sure that you're very comfortable with graph data structure. This tutorial is a part of the data structures and algorithms class. First, what is a depth first search algorithm? Just like the breadth first search algorithm that we had before, depth first search is a graph algorithm that's gonna visit all the nodes and only visit a node one time. Every single node in the graph will be visited only one time. And the difference between depth first and breadth first is, with depth first search, we're gonna search as deep as we can first. You may ask how deep? It's as deep as we can no longer go further. So it's as deep at the end of the graph. And after we finish one depth, we're gonna explore the next new possible depth. So let's have a look at our graph. This graph is being explored by depth first search. Our starting airport is SFO, and from here we're gonna go far away from SFO as we can, meaning we're gonna go as deep as we can into the graph until we cannot go any further. So if we start at SFO, the first path we're gonna explore is SFO to DEN to IAH. That's the first depth, and when we reach the end, we can explore the next depth, which is JFK right here. So the next path from SFO to the end is SFO, DEN, and JFK. Remember, we don't revisit SFO and DEN. We only visit the next nodes that we haven't visited, which is JFK in this case. The green two bars here is the second depth that we're gonna explore. And as you can see, our last depth is this one, ORD, with the triple bar in purple. So if we run a depth first search on this graph with this setting, the pattern of node discovery is gonna look like this. We're gonna have SFO, DEN, and IAH in the first depth, JFK in the second depth, and ORD for the last depth. And to achieve this kind of pattern, exploring the graph as deep as we can first, we're gonna use stack data structure. And how it's gonna go is, so we start as SFO, then SFO go to the stack, and we pop the stack. We have SFO. We know of DEN and ORD, so we push them into the stack. And for the next iteration of the while loop, we're gonna pop the stack again, and we're gonna see DEN. When we have DEN, we know of ORD, JFK, and IAH. But we already seen ORD, so we're gonna ignore ORD and push JFK and IAH into the stack. And we're gonna keep popping and pushing until our stack is empty. And if we record the nodes, this is the sequence of the nodes we're gonna see. With our second example, we change our starting node from SFO to DEN. Because we start here, DEN at the beginning, we're gonna see all the nodes. And it's gonna push all the nodes into the stack. And if we explore the graph from DEN, we're gonna have 4 possible depths, which is IAH, JFK, ORD, and SFO. That's what we're gonna see in the sequence of the nodes visitation. The usefulness of depth first search is to solve problems that visiting the nodes in this particular pattern, depth first, is useful. This is one way to think and solve your problem. And in fact, a lot of problems can be solved by this pattern of node visitation, depth first. And remember to always use stack to implement depth first search. Next, we're gonna see how to implement depth first search in the simplest form, the purest form of depth first search. So this is the bare bone depth first search implementation, and any more complicated implementation of depth first search is just adding more code logic to this implementation. So remember how to do depth first search simplest implementation is very important because it's the base for anything else. And you must be very comfortable doing this before trying anything more complicated than this. First, we're gonna have the graph to show the relationships between the airports. Next, we have the airport detail information, and here is our depth first search in purest form. It's quite simple. Our depth first search, we're gonna take in the starting node, we initialize the result, a set of node that we have seen, and we initialize our stack. Now, remember to use a proper stack data structure in real life. Here, I'm just using an array, and the popping and pushing of an array is not as efficient as the real stack data structure. Here, we print out a starting node, and then we're gonna iterate throughout the nodes. We're gonna use a while loop, as long as we still have node in the stack. First, we're gonna pop the stack, And if we have never seen the node before, we're gonna process it. Otherwise, we're gonna ignore the node. Then for this node that we have never seen, now we've seen it and we add it into the seen list. Then we're gonna get all the neighbors of the node. And for each neighbor, if we haven't seen the neighbor before, we're gonna put it into the stack. Then we're gonna save the current stack name into the result array. We print the result array in each iteration, and then we're done. So if we run our depth first search with a starting node of 0, which is SFO, like this setting that we have here, this is the result we're gonna have. We have starting node of SFO, and each by each, we're gonna visit all the nodes in a depth first pattern. If we change our starting node to DEN, which is 2, our starting airport now is DEN, and the order of node visitation gonna be like this. 4 depths that we're gonna visit from DEN.